Hello, and welcome to Module 7.4, Elimination Using Multiplication. Our objective for today is that I can solve systems of equations by eliminating a variable using multiplication and addition. So, our vocabulary, and really it's more just a key concept, is when are we going to use multiplication? It is going to be when your coefficients are all different. So in the previous lesson, we taught you that you can use elimination either by adding or subtracting two equations together to eliminate or cancel out one of the variables, and then you can use that to solve for the remaining variable, substitute back in, and get your solution, your ordered pair. In this case today, we're going to look at the fact that none of our variables are going to be the same. So we have our x's are 10 and -5, our y's are -7 and 3. So we can't just straight add these together and have something cancel out. We need to multiply because our rules of multiplication say if I have a true equation and I multiply all parts of it by the same value, I will have a true equation still. I will have an equivalent equation. So that's what we're going to do here. We are going to multiply in order to get an equivalent equation. So we're going to look to see what is my easiest variable to find something to multiply by. And what I'm looking for is, ideally, do I have a variable that has opposite signed coefficients that I could maybe multiply one or the other to get it to match its corresponding one. So what do I mean by this? Well, if I look at this, I could multiply -5 by 2, and that would be -10. And now I have opposites. I have additive inverses, right? I can't multiply either 7 or 3 by something to cancel that out. We'll get to that a little bit more later. So the first one I want to look at is multiplying by 2. So we're going to multiply that bottom equation by 2, and we're going to cancel our x's. So my top equation remains exactly the same. 10x minus 7y equals 2. My bottom equation, we're going to multiply, and now I'm going to have -10x. I'm going to have plus 6y, and that is going to be equal to -6. All right. Now, my next step is going to be add these two equations together. The 10x and -10x cancel out. -7y plus 6y is -y. 2 plus -6 is -4. And my final step is to divide by -1. And I get that y is going to be equal to a +4. Now we are back exactly where we were at the beginning. We're going to substitute our value into one of these equations and then work with it. So I'm going to substitute it into the one that I did not manipulate. I'm going to use the 10x. So we have 10x minus 7 times our y value of 4 is equal to 2. Okay, so we do the multiplication. We have 10x minus 28 is equal to 2. We're going to add 28 to both sides. 10x equals 30. And then lastly, divide by 10, x equals 3. So my ordered pair, the point in which these two lines are going to intersect, is 3, 4. So as we go to the next page now, we are going to use the other equation to verify our answer works. And again, we are going to go back to the original equation as it was originally written. This is our check to make sure that we didn't make a mistake as we were converting this equation and multiplying by 2. So we go back to the original. So we have -5 times x, which is 3, plus 3 times y, which is 4, is equal to -3. -5 times 3 is -15. 3 times 4 is 12, equals -3. -15 plus 12 is -3, is equal to -3. All right, and that does check out, so my solution does work. All right, now let's look at letter A. Letter A, As I'm looking at this, I see that 8x and negative 4x are opposite signs, and that bottom equation is something that I could easily multiply by to get it to be an additive inverse of the top. So I'm going to multiply the bottom equation by 2. So my top equation remains the same. 8x minus 3y is equal to 4. My bottom equation, we do that multiplication, I get negative 8x plus 8y is equal to 16. We add our two equations together. The x's cancel out. Negative 3y plus 8y is 5y, and 16 plus 4 is 20. And now I just divide both sides by 5, and y is equal to 4. Now, I'm going to use one of my equations. I'm going to choose the bottom one. So we have negative 4x plus 4 times, I substitute in 4, is equal to 8. Now, negative 4x, we're going to add 4 times 4 is 16 equals 8. Subtract 16 from both sides. We get negative 4x is equal to negative 8. And we divide by negative 4. We get that x is equal to positive 2. So the ordered pair is 2, comma 4. That is my solution. That is the point in which these two lines are going to intersect. Letter B. We're going to start off with looking at this, and I see my x's. I got negative 2x and 3. I would have to multiply both of those by something, but 12y and negative 4y, I see that I can multiply that by 3, and that is going to get me an equivalent equation. So my first one is still negative 2x plus 12y is equal to negative 30. My second one, when I do that multiplication, I get 9x minus 12y is equal to 51. Okay, now we add these two equations together. My 12y and negative 12y cancel out. Negative 2x plus 9x is 7x. Negative 30 plus 51 is 21, which we divide both sides by 7, and x is equal to 3. Now I'm going to use the top equation as my check. So I'm going to take negative 2 times 3 plus 12y equals negative 30. My first step is to do that multiplication. Negative 6 plus 12y equals negative 30. We are going to add 6 to both sides. We get 12y equals negative 24. Divide by 12. Y is equal to negative 2. So my ordered pair is going to be 3, negative 2. Okay, now I want you to try letters C and D on your own, and then compare your work against mine as I go over them. Letter C. As I look at this, my bottom equation, I see that I can multiply that by 2, and I can get an additive inverse. So we'll have 6x plus 4y equals 42. That is going to stay. Negative 2 times negative 3 is negative 6x. 2 times 3y is 6y. And 2 times negative 6 is negative 12. Add those two equations together. X's cancel out. 6y plus 4y is 10y. 42 plus negative 12 is 30. And we're going to divide by 10. Y equals 3. Now I'm going to substitute that back into one of my original equations. I'm going to take the bottom one, negative 3x plus 3 times 3 is equal to negative 6. We are going to multiply. 3 times 3 is 9, which we are then going to subtract from both sides. Negative 3x equals negative 15. And lastly, we divide by negative 3. X is equal to 5. So my ordered pair, my solution, is 5, comma 3. Letter D. In this instance, nothing is opposite signs, but I can pretty easily multiply that bottom equation by a negative 2 in order for us to get some additive inverses. So we get 2x plus 3y equals 9. We're going to multiply. We get negative 2x minus 10y equals negative 16. We add our two equations together, and we get those to cancel out. We have negative 7y is equal to negative 7. Divide by negative 7. Y equals a positive 1. That bottom equation is perfect for us to use. So we're going to have x is equal to 5 times 1 equals 8. Sorry, and that's x plus 5 times 1 equals 8. 5 times 1 is going to be 5. And then we are going to subtract that 5 from both sides. And we get that x is going to be equal to 3. So my ordered pair is 3, comma 1. With all of these problems, you are able to have gone back and check your work against the answers and make sure that they all work. All right, so let's take a look at example 2. We're going to multiply by both equations in this one in order to eliminate one of our variables. Now, what does this look like? Well, letter A, this was me just using the exact same ones, but instead of eliminating x, what if we looked to try to eliminate y instead? All right, so we can do that. We can multiply by 4, and we can multiply this by 3. Right, so what you're going to do is, when it comes to multiplying by two equations, you're going to look for equations that are opposite signs, so you don't really need to change anything all that drastically. So in our top one, we have 4 times 8, which is 32x. We have 4 times negative 3 minus 12x. And we have 4 times 4, which is equal to 16. Our second equation, 3 times negative 4, is negative 12x. 3 times 4y is plus 12y, and that's a y there, not an x. And that is going to be equal to 24. Now we need to add these two equations together. 32 plus negative 12 is going to get me 20x. Negative 12y plus 12y cancels out, and 16 plus 24 equals 40, which I can then divide both sides by 20, and I get that x is equal to 2. I'm going to use the top equation. I'm going to substitute that back in. So we have 8 times 2 minus 3y equals 4. So if we go ahead and multiply that, we get 16 minus 3y equals 4. We are going to subtract that 16. Remember, we're subtracting because the sign in front of a number is the one that is attached to it. So we have negative 3y is equal to negative 12. And the last step, we divide by negative 3. We get that y is equal to a positive 4. Okay, y is equal to positive 4. Now we're going to look at letter B. In this case, again, we're going to go the more complex route. We're going to look for something we can multiply both equations by in order to find an additive inverse. And we're going to have that with our x values. So I'm going to multiply my top one by negative 5. I'll multiply the bottom one by 3. And now my x values will be what my additive inverses are. So the top equation, negative 5 times 3 is negative 15x. We have plus 30y is equal to negative 105. And let me fix that so it looks a little better. Negative 105. And our bottom one, we multiply and we get 15x plus 9y is equal to 66. I'm going to add these two equations together. My x's cancel out, and I get 39y is equal to negative 39, which I can divide by 39 on both sides. Y is equal to negative 1, which I'm going to substitute back in. I'll use the top equation. So we have 3x minus 6 times negative 1 equals 21. Multiply that out. 3x plus 6 equals 21. Subtract 6 from both sides. 3x equals 15. And lastly, divide by 3. X equals 5. So we have 5. Negative 1 is our ordered pair. All right, so now we're going to go on to the next page. And these, there is no two ways about it. There is only one option in order to solve these, and you're going to go ahead and do that as a you try, and then come back and check your work against my examples. All right, so our first example here. I have opposite signs on my y's, and so that is what I'm going to work with. So I'm going to multiply my first equation by 3, my second equation by 4 in order to get those y's to be opposite. We're going to that least common multiple there. All right, so we get 9x plus 12y equals negative 75. For my first equation, I get 8x minus 12y equals 24 for my second equation. Add them together. The 12y and negative 12y cancel out, and I have 17x. Negative 75 plus 24 is negative 51. Divide both sides by 17. X is equal to negative 3. Now I'm going to substitute that back in. I'm going to use the bottom equation for this, I'd say. And so I'm going to do 2 times negative 3 minus 3y equals 6. Negative 6 minus 3y equals 6. Add the 6 to both sides. Negative 3y is equal to 12. And then when I divide by negative 3, I get that y is equal to negative 4. So my ordered pair is negative 3, negative 4. All right. Now let's examine letter D. We are going to multiply. I see my x values are opposite signs. So we're going to go ahead and, well, actually my y values are opposite signs too. Let's eliminate y. Those are smaller numbers that we got to work with. Let's do that. So we're going to eliminate y. So that means I'm going to multiply my top equation by 2, my bottom equation by 3. You'll notice we're just, in most of these instances, we're multiplying by what the opposite variable is so that we can get those additive inverses, right? We're looking for the least common multiple between these two values. All right, so let's go through that work. So 2 times 4x is 8x. That is going to be plus 6y, and that's going to be equal to negative 12. My second equation, we're going to get negative 9x minus 6y is equal to negative 39. Now we add these together. 6y, negative 6y cancel out. We get negative x is equal to negative 51, which we divide by negative 1. x is equal to positive 51. Ooh, that's a big number. But let's work with it. We're going to use the top equation to substitute it in. So we're going to do 4 times negative 4, or sorry, not negative 4, 4 times negative, or times 51 plus 3y is equal to negative 6. Now, 4 times 51 is going to give me 204 plus 3y equals negative 6. And we're going to subtract that 204 from both sides. And so we get 3y equals negative 210. Divide by 3, y equals a negative 70. So my ordered pair is 51, negative 70. So just because they're not always nice, neat answers doesn't necessarily mean they are wrong. All right, example 3, we're going to be writing and solving a system using multiplication. So we have a concession stand and it is selling a total of 138 small and large bags of popcorn. A small popcorn costs $2.50. A large popcorn costs $4. Total sales were $466.50. How many large popcorns were sold? All right, so looking at this, we need to first define our variables. How many small or large popcorns were sold? And we're talking about small popcorn. So I want to say X is going to be small and Y is going to be large. So those are my two variables, small popcorn and large popcorns. Now let's look at what we know. One equation. The concession stand sold a total of 138 small and large bags. That's going to be my first equation right there, right? So sold a total. When we see total, it tells us we are adding. So small plus large is going to equal 138. Well, my small is X, my large is Y, and that's going to equal 138 bags that were sold. Okay, that's our first part. Now our second part. Small popcorn costs $2.50. Large popcorn cost $4. Total sales were $466.50. So my second equation is going to stitch together the information about the costs. So a small bag of popcorn, we have 2.5x. Okay, $2.5, $2.50 times the number of small popcorns plus 4 times y, $4 times the number of large popcorns is equal to 466.50. Now we're going to multiply one of these two equations, and I'm going to see that multiplying the top one is going to be my easiest thing to work with. So we're going to multiply that by a negative 4. And we're going to cancel out y's. Instead of, I could multiply by 2.5, but I'd rather work with the whole numbers and look at it this way. So when we multiply that, we get negative 4x minus 4y equals negative 552. And I'm just going to slide my other equation over, and it's going to bring those parentheses and the y with. All right, so we're going to slide the other equation over right there. Okay, so now we can add these two equations together. Negative 4 plus 2.5 is negative 1.5x. And that's going to be equal to negative 552 plus 466.5 is negative 85.5. My next step, divide both sides by negative 1.5. All right, and I get that x is 57, and that's small bags. But does that actually answer the question we're being asked? No, the question is asking how many large bags. So we have 57 plus y is equal to 138. We're going to subtract that 57 from both sides, and we get y is equal to 81 large. All right. So the concession stand sold 81 large bags of popcorn. All right, now let's look at letter B. A hotel. This hotel is going to offer two different activity packages. One of them costs $192 and includes 3 hours of horseback riding and 2 hours of parasailing. And then the second costs $213 and includes 2 hours of horseback riding and 3 hours of parasailing. What is the cost of 1 hour of each activity? All right, for this one, we want to solve for both. So we're going to say X is going to be horseback, Y is paragliding. Okay, HB and P, or parasailing. Parasailing, not paragliding. So PS. All right, now let's look at our equations and let's kind of stitch this together. Two activity packages. One cost is $192 and has 3 hours horseback, 2 hours parasailing. So we don't know what the cost is, but we can set this up. We know 3x plus 2 hours parasailing, 2y, is going to be equal to 192. I know my second equation is 213, and you've got 2 hours on horseback and 3 hours parasailing. So we have 2x plus 3y equals 213. Now, we are going to have to multiply both of these equations. So I'm going to multiply the top one by -2, and I'm going to multiply the bottom one by 3. And this is going to allow us to eliminate our x variables first. So when I do that, I'm going to get -6x minus 4y equals -384. Bottom equation, I'm going to get 6x plus 9y equals 639. We're going to add these two equations together. -4y plus 9y is 5y. -384 plus 639 is 255, which when I divide by 5, I get that y is equal to 51, and that's dollars for parasailing. So to go parasailing, it is $51 per hour. Now I need to substitute that back into one of my two equations to find my value for horseback riding. So I'm going to use the bottom equation. So we've got 2x plus 3 times 51 is equal to 213. And when you multiply that, 2x plus, that's going to be 153 equals 213. Now we're going to subtract the cost, 153, of the parasailing from both sides. So now we're left with 2x is going to be equal to 60. So the $60 part of the activity is the horseback riding, which we divide by the 2 hours that you went, and you're going to get a total of $30 for horseback. All right. There are now 2 you-try problems for you to work through on your own. I want you to do those, and then you're going to check your work against mine. All right. Letter C. We have half a pepperoni pizza. Half a pepperoni pizza plus 3/4 of a ham and pineapple contains 765 calories. A quarter of a pepperoni plus a whole ham and pineapple is 745 calories. How many calories are in a whole pizza for each variety? right, so we need to know both variables, so we're going to solve for both. So x is going to be pep, y is going to be ham and pineapple. Yuck. All right, so our first equation, we have 0.5x, so 0.5 times a pepperoni, plus 0.75y is going to be equal to 765. Okay, our second one is going to be 0.25x plus a whole pineapple, so plus y is going to be equal to 745. I'm going to slide this over just a bit. Give me a little bit more room to work with. All right, now in order for me to make this work, I'm going to need to multiply that bottom equation, and I'm going to multiply it by -2 so that my x's will cancel out. Now my top equation remains the same, so we're still going to have 0.5x plus 0.75y equals 765. My bottom equation, now that I'm going to multiply, is going to be -0.5x minus 2y equals -1480. -1490, not 80, 90. All right, now we are going to add these two equations together. The x's cancel out. 0.75 plus -2y is -1.25y, and that's going to be equal to the -725. Divide by -1.25, and I get that y is going to be equal to 580 calories, and that is for the ham and pineapple. Now I'm going to substitute that back into one of my equations. I'm going to take the bottom one because I don't have to multiply by anything. 0.25x plus 580 equals 745. We're going to subtract 580 from both sides, and you're going to get 0.25x is equal to 745 minus 580 is 165, which I will then divide by 0.25. So x is going to be equal to 660 calories for the pepperoni pizza. Okay. Letter D, we're going to define our variables. X is going to be 8 by 10. Y is going to be wallet. My first equation, we have 2 8 by 10s and 4 wallets, and it's $52. 2x plus 4y equals 52. My second, 3 8 by 10s, 2 wallet, $50. 3x plus 2y equals 50 even. So we are going to multiply this bottom equation, and we're going to multiply it by -2. So I'm going to get -6x minus 12y equals -100. My first equation remains the same at 2x plus 4y. Why did I say minus 12y? It's going to be minus 4y. All right, 2x plus 4y is equal to 52. All right, now add the two equations together. 2x plus -6x is -4x. 4y, negative 4y cancel out. 52 minus 100 is negative 48. Divide both sides by negative 4. X is going to be equal to $12, and that's for an 8 by 10. So an 8-inch by 10-inch picture is going to get you $12. All right. Now we need to use one of our two equations. I'm going to use the top equation. So we're going to do 2 times 12 plus 4y equals 52. Multiply that, that's 24 plus 4y equals 52. Subtract that 24 from both sides. 4y is equal to 28, which will then divide by 7, and y is equal to $4. Sorry, we're dividing by, not 7. 7's the answer. We're going to divide by 4. We're dividing by 4. Y is going to be equal to $7 for a wallet. So 8 by 10s are $12 a piece, and wallet sizes are $4 a piece, $7 a piece. All right, we're going to go on to the next page now. Finding numbers of solutions. So in this case, I am going to multiply one of these equations. I'm going to multiply let's do the top one. I'm going to multiply the top one by negative 1. And when I do that, I'm going to rewrite it down below. I get 2x minus 5y equals negative 7. Now, when we were doing just the addition and subtraction methods in lesson 7.3, we said this could be a subtraction one, and I gave you a preview of you can think of subtraction as distributing that negative sign and multiplying everything by that negative sign. This is the way that would work out. That equation is now gone, and we have flipped the signs of everything by multiplying it by negative 1. So now when I add these together, my negative 2x and 2x cancel out. My 5y and negative 5y cancel out. So on the left side of the equal sign is 0, right? Because negative 2 plus 2 is 0. Negative 5 plus 5 is 0. The right side, 12 plus negative 7, is going to be, was that negative 7? Yeah, that'll be negative 7. And that's going to give me 5. So this is going to be no solution. Okay, no solution, because 0 does not equal 5. All right, let's take a look at letter B. In this one, as I look at it, I'm going to multiply by negative 4, because that's going to get my x to be opposite values. So the first equation, 12x minus 8y equals 20. The second equation is going to be negative 12x minus 8y equals negative 20. And we're going to add these together. Those cancel and those cancel. So 0 is equal to 20 plus negative 20 is 0. So that is going to be infinitely many solutions. Those are going to be the same line, and they're going to be infinitely many solutions because they're the same exact line. They will overlap and intersect at every single point forever and for always. Now, that's the end of our main notes. If you would like to stick around for a couple extra examples, I have 4 extras here that I'll work my way through. If you're done, you can check out of the video here, and I hope you have a great night. If you would like to walk through these 4 extra examples, stick around, and I'm going to walk you through all 4 of them right now. All right, letter A. As I analyze this one, I see that they are all the same sign, so I'm going to have to multiply one of them by something that's an opposite sign And I'm also going to have to multiply it by something to cancel a variable. So I see 5x and 10x, so I can easily multiply that top equation by negative 2. So I'll get negative 10x minus 4y is equal to negative 24. And I'll rewrite the second equation. 10x plus 4y is equal to 0. Now, add the two equations together. My negative 10x and 10x cancels out. Negative 4y plus 4y is canceled out. Those are all both zeros. All right, negative 24 plus 0 is negative 24. Is 0 equal to negative 24? No. So these are no solution. Okay, they are parallel lines. They are same slope, different y-intercept. If we were to solve them for y, there is no solution to this set of equations. All right, letter B. I have 3x plus 4y equals 6. I have 5x plus 2y equals negative 4. Looks like I can multiply 2 by negative 2 to make it an additive inverse with the first equation. So that's what I'm going to do. My first order of business is to multiply here by negative 2, if the pen will cooperate. And so I'm going to get negative 10x minus 4y is equal to 8. That first equation stays the same, so 3x plus 4y is equal to 6. Now we want to add these two equations together. 3x plus negative 10x is 7x, negative 7x, is equal to 8 plus 6 is 14. Divide by negative 7, and we get x is equal to negative 2. I'm going to substitute that back in, and I'm going to put it in the top equation. So we have 3 times negative 2 plus 4y equals 6. So that's negative 6 plus 4y equals 6. Add 6 to both sides. 4y equals 12. Divide by 4. Y is equal to 3. So my ordered pair here is negative 2, 3. All right, if I go down and look at letter C, I can multiply that bottom equation by 3 to get it to be the opposite, negative 15x. If I multiply 5 by 3, I get positive 15. So let's rewrite the first equation. Negative 15x plus 9y equals negative 24. Multiply the second one, negative 15x. Sorry, 15x. Okay, and 3 times negative 3 is minus 9y, and 3 times 8 is 24. Negative 15 plus 15, 0. Negative 9 plus 9, 0. So left side of the equation is 0. Negative 24 plus 24 is 0. That is true, so this is infinitely many solutions. And letter D. If I look at this one, I could multiply my first equation by negative 2. And so I'll get negative 4x minus 10y is equal to negative 22. Second equation remains the same. 4x minus 3y is equal to 9. Add the two equations together. My x's cancel out. Negative 10y minus 3y is negative 13y. Negative 22 plus 9 is negative 13. Divide by negative 13. My y value is equal to 1. I'm going to use the top equation to find my x value. So I have 2x plus 5 times 1 is equal to 11. 5 times 1 is 5 equals 11. Subtract 5 from both sides. 2x is equal to 6. Divide by 2. And my x value is going to be 3. So my ordered pair is 3, 1. Thanks for sticking around for the bonus examples. If you have any questions over any of this, please feel free to bring it to class tomorrow. Otherwise, I hope you have a great day.